Hi guys, so for today's lesson we're going to be dealing with gradient. So first up, one of the key words that I want you guys to be, or key sort of phrases or terms that I want you to be aware of is the rise and run of a line. You need to be aware what rise means and what run means, and that's associated with some sort of line. So all lines have a vertical rise and a horizontal run. So for example, look at this line here in black. You can see that the rise of this line that I've highlighted, the rise is right here, this length. So that's like 3 squares there. So that rise would be, say, 3. And this is the run down here. So always think that rise is just vertical and run is horizontal. So rise is 3 and the run is, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in this case. So rise is 3 and the run is 12. So, and also here, the rise would be that many squares, the run would be that long. So yeah, so all lines you can pretty much make like a right angled triangle underneath. And with that triangle you can see the rise and run of a line. Next word we want to understand is this word gradient, and gradient has the symbol M. I know it's a weird letter to use for gradient, but it's just something you're going to have to take on board. So it's a number that measures the slope of a line. It's found by dividing the rise by the run. So gradient has a formula, M equals rise over run. It's definitely something you're going to have to commit to memory. So it's all about a number that describes the slope. So for example, let's consider this line here. We can find the gradient of this line by going rise divided by run. So in this case, we've got 3 divided by 12, and that simplifies to 1/4. Notice here I put M, and next to the M down in the bottom right corner, I've put PQ there to show you that it's the gradient of PQ, because our line, in this case, goes from P to Q. And yeah, so our gradient is 1/4. So the quarter represents this this gradient here. The 1/4, don't worry too much like why it's that number, but pretty much just think the top is your rise and the bottom is your run. You can kind of see this this relationship with the triangle. You can see that for every single one that it rises, for example. So say there's one rising, you can see that it goes across by 4. So you can see the 1 over the 4, and you can still see, and you can keep seeing this pattern of 4 to 1 each time with this line. So that's why it simplifies to 1/4. But okay, so anyway, let's move on. So positive gradients, what are they? The slopes that go uphill from left to right. So if we see that it's going uphill like this line from left to right, yeah, we can see that it's going uphill. So we know that this gradient has to be some sort of positive number. So it's got to be bigger than 0. Negative gradients, numbers less than 0, are slopes that go downhill from left to right. So left to right, it's going downhill, so that gradient has to be negative. Next one is a 0 gradient. So it's the gradient of a flat line. So here we've got a 0 gradient line, it's flat. And the reason is because the rise, it doesn't rise at all, it's always flat, so the rise is 0. And we can see that it runs along 9. And so gradient's going to be 0 divided by 9, and that's going to be equal to 0. So that's why the gradient is 0. Next up is an undefined gradient you need to be aware of. So that's the gradient for vertical lines. The reason that it's undefined is because, so for example, with this vertical line right here, you can see that the line rises, it goes up 6, and but it has 0 run. It doesn't run left to right at all. So therefore the run is 0. If we do rise divided by run, you can't divide by 0. So therefore that's when you get an undefined number, and your calculator come out as like an error. Okay, so let's do some example questions here. So find the gradient between 5, 4 and -2, -3. So how do we find the gradient between these 2 points? Well, at the moment, the best way to do it is to literally graph these 2 points on the number plane and then make your triangle underneath. So you can see your rise and your run. So once we do that, you can see the rise is 7 and the run is 7 just by counting the squares, or you could pretty much just find the distance between like the x coordinates and the y coordinates. And because our rise and run are both 7, we're going to get 7 divided by 7, and that gives us 1. Because it's an uphill line, we know it has to be positive 1, not negative 1. Okay, let's do another. So graph a line that has a y-intercept of 3 and a gradient of -4. So we want to think to ourselves, how can we make a line that satisfies these two sort of conditions? So the strategy is that you want to start with the y-intercept point of 3, and then make a triangle with the correct rise and run that matches this -4 gradient. Okay, so first up, notice how I've started with the point on my y-axis, the y-intercept of 3. I know it has to go through this point right here. And I also know that my rise and run has to be -4 over 1. Like the gradient was -4, but we need a fraction for rise and run. So I just literally change my -4 to a fraction. I make it -4 over 1. So I need to rise -4. That's like going down 4. And then I need to run 1 across. So you'll notice from this point here, I went down 1, 2, 3, 4. I went down 4, and then I ran across 1. And so I got another point on my line right here. And then what I can do with these 2 points is draw a straight line straight through them. So then we get this sort of line here, straight through those 2 dots. So that line there has a y-intercept of 3 and a gradient of -4. You can see that from left to right, it goes downhill. So it's definitely negative. Okay, good luck with the questions.